Okay guys, before we get into this video, you'll notice that only a few people are subscribed to my channel. So most people who actually watch my content aren't subscribed. So if you do me a huge favor, please subscribe before you get into this video, and I'd really appreciate that. Welcome to Khetz, and in this video, I'll be covering a few things about algebra. So basically there are a lot of things related to algebra. I'm just going to cover the most common ones. So let's get right into it. So to start with, I'm going to talk about products. So if you have a bracket with another bracket, this basically is a symbol, or this shows that you actually multiply these two brackets over here. So this bracket multiplies that bracket, right? That's what that basically means. So if you have values in here, for example, let's just say you have one term in here which is 2a, and here you have a plus 3b. If you're asked to find the product of these two, what you basically do is to just take the terms on this side and multiply them by each of the terms on the other side of the bracket or on the other bracket. So to find the product of this, it's simply 2a multiplied by one part of the second bracket and added 2. So you basically carry the sign of whatever this is. So you carry the sign of the product of these two, or you just add and carry the sign of this one and that one. So basically you just have 2a multiplied by 3b again. So don't forget this sign over here. If it were negative, so if you had something like this, let's say 2a multiplied by a subtract 3b. So what you basically say is that if you multiply 2a and a, you then add, you can just take 2a as it is and take the sign which is associated with this 3b and carry that sign over there. Or you can either take that sign to the outside and actually just multiply through right away and just say negative over there so that this can actually be positive. You should get the same answer. But what I'm trying to bring home is that if you have products, you don't necessarily have to write this down. What I'm saying is if you have products, you basically just multiply each of the terms on the left with each of the terms on the right. So whatever number of terms that you have, that's how you basically compute the product. So for example, if you had more terms, if you had something like 2x plus 3 multiplied by x squared subtract x plus 1. If you multiply these two, you basically start by multiplying your 2x with your x squared, then moving on to multiplying your 2x by your negative x, then multiply your 2x by your 1. Then again, you come here and say, so whatever number of terms you have here is going to be multiplied by the number of terms that you have on the right side. So let's do this one. So you'd multiply your 2x by x squared, that would give you 2x cubed. You'd multiply your 2x by your negative x, and that would give you negative 2x squared. You multiply your 3x by, so you multiply your 2x finally by your 1 over here, which would give you 2x. Then you'd move on to the next term because you've essentially finished all the terms on this side. That should be multiplied by your 2x. So now you move on to 3, which is the second term in your first bracket. So you'd multiply that 3 with x squared and you'd get 3x squared. You'd multiply your 3 with negative x, you get negative 3x. Multiply your 3 finally with 1, so it stays the same. Anything multiplied with 1 stays the same. So basically now, all you're left to do is to group the like terms, or just to add the like terms, terms which have the same variable and exponent. So basically, you only have 1x cubed, so that is the only one that has 2x cubed over there. So that is the only one. Then you have 2 which are associated with x squared, therefore you're going to say 3 subtract 2, which is basically x squared. Then you have 2 as well which are associated with x, so you're going to say 2 subtract 3, which is negative 1, so you're going to have negative x. And then finally you only have one constant, so you don't add it to anything, it's just as it is. So this is essentially the result of multiplying these two brackets. So your final answer would be this. To multiply each of the term in the left bracket with each of the terms in the second or the bracket to your right. Now here's an interesting thing which is going to help you to actually compute some of these common brackets. So if you have x subtract y, or whatever values which you have, whatever terms you have inside these brackets. So let's just say you had whatever, then x can be whatever, it can be 2, it can be another variable, whatever the case may be. What I'm bringing across is if you have a bracket squared, you can basically say, so let's say, let's call this T1, let's call this T2. You can basically say the result of this bracket is T1 squared plus 2 multiplied by T1 multiplied by T2 plus T2 squared. This is what I'm bringing across. So if you have a bracket squared, you can just take this term, square it, take this term, square it, and put each of those at the left end and the right end, and then in the middle you'll have 2 multiplied by that, which is what I have over here. Right? 2 multiplied by term 1 multiplied by T2. So let's check if this is actually correct by computing x subtract y squared. So this would lead us to write in both of these brackets. So we're going to have x multiplied by x, we're going to have x squared, and then subtract xy. Then we're going to have minus xy, then we're going to have plus y squared. Then we're going to have x squared. The result of this is going to be negative 2xy plus y squared. And this actually confirms that whatever you have, term 1 and let's say term 2, the result of this would be term 1 squared and term 2 squared on the other side, and in between you're going to have 2 multiplied by term 1 multiplied by term 2. That is going to be your result, or that is going to be your answer, and that is proven at the bottom of it here. So whenever you have something like this, you don't necessarily have to split this. You can just quickly come to your answer. Okay, so let's move along. Moving along, we can look at something like factorization next. So let's look at factorization. So in this section, I'm also going to show you another kind of shortcut or something like that. And before we move on to that, I just want to once again bring you to something which you should know. So if you have term 1 squared subtract term 2 squared, then you basically have a difference of squares, and the result of this would be term 1 subtract term 2 multiplied by term 1 plus term 2. So this applies in every case. So for example, if you had x squared minus y squared, the answer to this, or the result of this, would be x subtract y, and x plus y. We can prove this by multiplying through and check if it will give us the original equation. That would be x squared plus xy subtract xy, and then here you're going to have negative. You're going to have the negative of y squared. So this part cancels out, and you're only left with x squared minus y squared. So whenever you have something squared to subtract another term squared, then you can just basically say it is equals to this. That is going to be quite helpful in the coming sections or in whatever application which you want to apply that to. So moving on to factorization, that is also going to be helpful to us when we talk about factorization. It's called difference of squares. So this is difference of squares, the difference of squares formula, right? So difference of squares, right? Let's move on to factorization. Now in factorization, we're basically interested in finding brackets which are the equivalent of a certain, so whatever number of brackets which are necessary to symbolize the factors which form an equation. So if you have an equation, for example, let's say you have 2x squared plus 5x plus 2. This is a quadratic formula because we have the highest power as 2, right? Our highest power is 2. So that qualifies as a quadratic formula. We expect at least 2 brackets, or at most 2 brackets, to actually symbolize the factors which actually form this equation. So now here's a trick for quadratic functions which you can basically use to find those factors. So here's a trick which I use. So you basically start here and take whatever the coefficient of x squared is, then you're going to take the last part, which is usually a constant, or which is always a constant. So you're going to multiply these two, and then after multiplying these two, so you're going to have 2 multiplied by 2 in this case. So you're going to have 2 multiplied by 2, and the answer to that is 4. Now you have 4 over here and it's positive. We are looking for the factors of 4 which, when you multiply, so basically when you multiply those factors you get 4, and when you add those factors you get your middle term, and our middle term in this case is plus 5. So what factors of 4 will give you 4 when you multiply them, but will give you 5 when you add them? So that is simple. It's just 4 and 1, right? Those are the two simple factors which you actually look at. Excuse me. So multiplying 4 and 1, you get 4. Adding 4 and 1, you get 5, which is the middle term. So what do you do with these terms? So basically just break your 5 down into these terms, or these factors of your multiplication of this and that. So you're going to have 2x squared, then you're going to have plus 4x, then you have plus x plus 2. So I basically just broke the 5 into the factors of 4, right? And then now you're going to say, you're going to factor out 2x for this and that. You're going to factor out 2x, then you're going to have x left here, then you're going to have 2 left here. Then here you're going to factor out 1, you're going to have x plus 2. So your aim is always to have some brackets which are the same. So you see that this bracket over here is the same as that bracket. So which means we can actually say, can factor out that bracket, and we'll be only left with 2x plus 1. So that is what we're going to have in the second bracket, which is 2x plus 1. And that is basically your answer. That is your answer for the factorization of this original formula which we had up here, right? For this original formula of 2x squared plus 5x plus 2, if you're asked to factorize that, you'd actually have this as your answer, right? Now moving on to higher powers, let's say you had something like the cube root, or let's say you had the highest power in your formula as 3. So you can get something like this. Let's say you had the highest power as 3, and you were given like one of the factors of that. You're given one of the factors and you're told that that is one of the factors. So what will be the second bracket of this, right? What will be the second bracket? So you're asked to input the answer here. So what is the answer here, given this one bracket? So now even with numbers, let's say you're given 6, and you're told that 6 is equal to 3 multiplied by something. To get this something, let's call it x. To get this something, you basically just say x is equal to 6 divided by 3, and your x would therefore be equals to 2. So the same thing applies when you have formulas, right? We can divide formulas. So we're looking for this part, this question mark over here. So this question mark is equals to 6x cubed plus 17x squared plus 11x plus 2 divided by your 3x plus 1. And we can actually use long division to find the answer to the bracket, or this question mark which you're actually looking for. So then let's start. You're gonna have our 3x plus 1 over there. you're going to have your 6x cubed, then you're going to have plus 17x squared plus 11x plus 2. So this is how you compute your answer. So you're going to say 3x into 6x cubed. What is the answer to that? The answer to that is 2x squared. Now you're going to multiply that 2x squared with this whole bracket of 3x plus 1. We only divide by this one here, but we multiply by the whole bracket. So now you're going to multiply this 2x by your 3x. So whatever answer you get at the top, you're going to multiply it with your 3x plus 1 and not just 3x by itself, even though you divide by 3x by itself, right? So now you're going to say 3x plus 1 multiplied by 2x squared. You're going to have 6x cubed plus 2x squared. Then you're going to subtract that. So here you're going to get 0, then 17 subtract 2x squared. So 17x squared subtract 2x squared, you should get 15x squared. So now we're going to take this down here. Then you're going to have plus 11x. Then we're going to say 3x into this 15x over here. So the answer to that would be 5x, right? So plus 5x, write the answer at the top. Then the answer to 5x multiplied by 3x plus 1 would be 15x squared. Then 5x plus multiplied by 1 would be 5x over there. Then you subtract again. You're going to have 0 over there. Then you're going to have 11 subtract 5, which is 6. Then you're going to take the last term down here. Then you're going to finally say 3x into 6x, and the answer to that is 2, right? And then we have 2 over there. You're going to multiply that 2 with 3x plus 1, and the answer to that should be 6x plus 2. So this fits perfectly into that. So then we now have the answer to the second part, or the second bracket, and the answer to that is 2x squared plus 5x plus 2. So we can actually say that your 6x cubed plus 17x squared plus 11x plus 2 is equals to the given 3x plus 1 and the value which we now found multiplied by 2x squared plus 5x plus 2. Now, if you asked to simplify this second bracket further, you'd see or you'd notice that this is the same bracket which we previously solved, and therefore the answer to that would just be x plus 2 plus 2x plus 1. So you're always required to simplify until you can't simplify anymore. So I do suggest that you actually simplify further by showing the steps. So you're going to simplify your 2x squared plus 5x plus 2 by showing the steps which I showed previously over here, right? Okay. So that is basically all that I wanted to talk about with regards to factorization. We're going to move on to the next topic under algebra, which is completion of squares. All right, so completing the square, if you like to call it that. So now I previously showed you that if you have x plus y squared or x subtract y squared, you basically have x squared plus 2xy plus y squared as your answer. So x, you're going to square the first term, you're going to square the second term, then you're going to multiply the 2 and then also multiply the result of that by 2. So 2 multiplied by this, multiplied by that would be your middle term. So now when we're asked to complete the square, we're given a certain formula and we're asked to make it a perfect square. Now this is a perfect square. X plus 3, for example, is a perfect square. We know that the result of this is x squared. Then we're going to square 3, it's 9. Then the middle term is going to be x multiplied by 3, which is 3x multiplied by 2, which is 6x. This is a perfect square. Now, if we are only given x squared plus 6x and we are asked to complete the square, let's say we're given this is a question and it said complete the square, right? what will you do? You basically now have to change this formula, or you basically have to add something to this formula which actually gives you this perfect square at the top, right? So what we're aiming at is to have this perfect square at the top given this formula over here. So let's use another example, because we already know that the answer to this one is +9. You basically just do this to turn this into a perfect square, right? So now I want to show you the working, or I want to show you how you'd actually compute that perfect square, or how you'd complete the square. So let's use another example to find this. So let's say you're given x squared subtract 12x, and you're asked to find something here which is gonna complete the square, right? So what is that something over here? To compute that part, here's what you basically do. You first make sure that the coefficient, so coefficient of x squared is 1. In our case, if you look at what comes just before x squared, we can tell that it's actually just 1. So that's what you first make sure of. Make sure that the coefficient of x squared is 1. So now that we have that in check, we can move on to the second step. Now the second step is basically to take, so let's say we have a general form of ax squared plus bx plus c. The second step would be to say that your c is equals to your b divided by 2 squared, right? And here we can actually apply this and see if that makes sense. So we're going to say our b in this case is -12. As you can see, you're going to say our c is equal to -12 divided by 2, and then we're going to square that. So if you say c is equal to that, then in here you have -6. -6 squared is 36. So now our answer would be x squared subtract 12x plus 36. That would be our answer. But now let's check if that is indeed true, or let's check if that can give us a perfect square. So we're going to do factorization just to prove this. So we're going to say we have 36. What factors of 36? If you basically multiply those, I'm just applying my factorization method. If you multiply the factors of 36, they give you 36, but if you add them, they give you -12. You'll notice that you have two values, which are -6 and -6. So if you multiply -6 and -6, you get 36. If you add these two, you get 12, right? -12. So you're going to do that. Then you're going to say x. Then you're going to have x subtract 6. Then you're going to take out 6 here. Then you're going to have x subtract 6 as well, which means we have x subtract 6 multiplied by x subtract 6. And the result of that is x subtract 6 squared, which means we've essentially transformed our original equation, which is over here, into a perfect square. It became a perfect square, as we can see from the final factorization over here. It became x subtract 6 squared, right? From this 36 which we added. So that is what completion of a square talks about. You basically just take a certain value and you compute the c value using your b. So you can actually manipulate the c value. Let's say you're given c and you're asked to find b, right, in this general form of the equation. Let's say you're given c and you're asked to find b. So you just basically manipulate this formula which you have over here, right? But in most cases, you're asked to find c, or in most cases, you're actually asked to convert. Let's say you're asked to convert this general form of ax squared plus bx plus c into something which looks like this. And this is usually when you're dealing with functions. And this is going to be helpful for you when you're dealing with functions, because when you're dealing with functions, you notice that your turning point is actually equals to P and Q. Those are the coordinates of your turning point, right? So if you can transform this form into that form, it's going to be quite helpful to you to answer a lot of questions actually. So let's say you were asked to convert ax squared plus bx plus c 2x subtract p squared plus q. So this is basically a square, or this is basically completing a square, right? So it's the same thing, or it's under the same topic. So let's do an example just to show how you basically do that, or how you'd actually do that. So let's say you were asked to transform, for example, you were asked to transform x squared subtract 4x subtract 12 to this form here. So here's what you do. So you first aim to complete this square. But now, if you complete that square, you notice that you'd actually change this formula over here. Now, if you change something, you have to fix it. So if I add, let's see, if I add 4, I also have to subtract 4 to cancel the effect of whatever I've done. But in the end, I'll have a square part and this factor part over here. We shouldn't change this, right? So if you don't want to change this after adding something, that is what the logic of it is. We don't want to change the formula x squared subtract 4x subtract 12, but we want to transform it into another form. But it doesn't qualify to be in that form currently because it's not a complete square, right? So we have to complete the square first by adding something. Now, to cancel the effect of whatever we added, we have to subtract something as well, right? So our b in this case is -4. So the c should actually be equals to b divided by 2 squared, as we previously talked about, which means we should expect to have 4 as our c. But look, we actually have our c as -12 over here. So what can we do to -12 so that it gives us 4? We can add 16 to it because 16 subtract 12 is equal to 4. So now that we're going to add a 16 to that, we also have to subtract 16 from that. So we're going to have x squared subtract 4x subtract 12. We're going to add 16 to that. But now that we added 16, we actually changed the equation. So to cancel the effect of this 16, we're actually going to subtract 16 as well. So now we're going to group this and just do this so that we have a square. So 16 subtract 12. We're going to leave this 16 out for now. -16 out because we want to focus on making a square. Now, to make a square for this one, we found out that our c has to be 4. So let's satisfy that part of making a square. So x squared subtract 4x, and then we're going to have plus 4 and then subtract 16. So this part forms a square, which is part of the form x subtract p squared plus q. So now I just have to say that we see that this is actually equals to x subtract 2 squared. This part is equals to that because if you square x, you're going to get that. If you square 2, you're going to get that. If you multiply x and -2, you're going to get -2x. Multiply that by 2, you're going to get this middle term, which means this actually satisfies the square part of the new form. And we know that the form or the answer to that is x minus 2 squared. And what's left is the -16 on the outside. And we have successfully changed the original equation of x squared subtract 4x subtract 12 into this form over here. And if you just multiply through and take it back to the original equation, you're going to come back here and you see that if you add everything up, you're actually going to get the original equation. So you should make sure that your completion of the square hasn't changed the original equation, because this is still the original equation, even because we added 16 and we subtracted 16, right? So that is how you basically complete a square. That is basically how you transform ax squared plus bx plus c into this form. And the same applies, I'm going to give you this as homework. The same applies if you had a negative. Remember, I said you first have to make sure that the coefficient of x squared is 1 before you do this completion. So basically, in this case, you'd factor out your negative and you'd have x squared plus 4x. So inside you'd have, actually this would be negative 4x, and then here they have negative 2 as well. So just leave this negative outwards, so you basically in the end have negative something squared then plus q, right? So this is homework to you guys, and the answer which you should expect is negative x subtract 2 squared plus 6. So I'm giving you this problem as homework, and you actually have to find this form. You actually have to transform it to x subtract p plus q. So the first step would be to make sure that the coefficient of, so you make sure that your a is equals to 1, or you make sure that the coefficient of the equation which you want to find the square of is 1. So the coefficient of x squared has to be 1. That is what you first make sure. We had a negative 1 here, so you just factor that out. And that factored out part is going to form this negative in the final answer, right? So that is all with regards to completing the square, right? So next we're going to move on to, I'd rather like close this video here because it's getting too long. I'm going to continue in another video and still talk about algebra. So I hope you found this helpful, and if you haven't subscribed, please subscribe, and if you like the video, just go ahead and give it a thumbs up. Please do check the next video which is going to follow this one. I'll be talking about simplification, simultaneous equations, solving for x, inequalities, and stuff like that. And not forgetting exponents, equations, and finally surds, right? So I'll see you guys in the next video.